Hey, I'm Michael. I'm a rising junior at Amber Valley High School, and this is the work I've done so far on my object tracking robot. Because it has no steering axle, I've added mechanism wheels to allow it to move in X and Z directions without steering, and if it does need to turn, these rollers will make there less friction. Most of the work I have done so far has been with electrical components and software. I began with the Arduino Uno, learning basic electrical components such as RGB LEDs, servo motors, and potentiometers, all the way to advanced ones including ultrasonic sensors, infrared receivers and remote controls, and stepper motors and their motor drivers. The purpose of this was to become well versed before I put them into the robot. After learning the ins and outs of the Arduino, I moved on to an ESP32 for performance and multi-threading. I eventually created a program that used both of its cores to run two tasks concurrently. It's basically an upgraded Arduino. It's smaller, faster, has built-in Wi-Fi and Bluetooth, and has two cores, so it will replace the function of the Arduino in the robot. I spent the majority of my time learning the master brain of the robot, the Raspberry Pi. After connecting the Raspberry Pi to a keyboard, mouse, and monitor, my first step was to set up a secure shell protocol, or SSH. This will allow me to control my Raspberry Pi's terminal from my laptop. This will be especially useful when the code is already uploaded to it and I will not have access to the monitor. I did SSH through PuTTY, which allows me to access its terminal from my laptop. One issue that I encountered was that the security in my internet router prevented the two computers from communicating with each other. This was fixed with a simple settings update. Then I used virtual network computing, or VNC, for further control. After creating an account and connecting the devices, I had full control of my Raspberry Pi through my laptop. This includes the terminal, file manager, and Visual Studio Code, my main code editor. This allows me to do all my software on one computer and show others my Raspberry Pi through screen sharing. Finally, I set up a GitHub repository. This enabled me to code on both my laptop and my Raspberry Pi with ease. Along with this, I learned all necessary Git commands that would allow me to transfer files and update code between the two computers. All of the progress I have made so far has been setting up for building and programming the actual robot. Now that I'm completed, I'm excited to finally be able to combine electrical components along with code and create a functioning robot.